So with this video, we're going to be talking about DMA 50, but it has some DMA 60 words. So you might see the 60 marking in my Math Plus, but we're actually going to be still sticking with graphs, just like we've been doing in DMA 50. The first topic we're going to talk about in section 15 is domain and range. Domain, this what it means is it mostly focuses on the x values. So the x values is going to be always the first number in an ordered pair. The range focuses on the y values in the ordered pair. So for this one here, since the ordered pairs are given for us, they just want us to state what the domain is and the range is for each of these ordered pairs. So the answer for this particular one is just be 7, -2, 1, and 4 to be the domain. The range is just going to be 1, -5, -2, and 7. So it's just basically just picking out the X and Y's for domain in the range. And if you have a listing of numbers twice, so say for instance we had a 7, then a 7, then a 1, and then a 4. In my Math Plus, you can just put 7 one time. So don't put 7, 7, 1, 4. Just make it, just write it, just type it in one time and they will accept it. That was for ordered pairs. So now let's go to input and output when we're talking about objects or words. So input is the same thing as domain, which again we're referring to the x values. Range is going to be the output. So for this here, we want to figure out what the domain is for the planets and the solar Congress representatives as far as the number of them. So Venus has 50 and Neptune has 50. So when it asks for the domain, this input would be considered to be the domain. So it would be Venus, Mars, Jupiter, Saturn, Neptune, and Pluto. The range will be the numbers. So this is for finding the domain and range for this type of problem. Now the question on my Math Plus is it going to be a function? How do you know if something's going to be a function? As long as the domain does not repeat, meaning that how many times do you see Venus leave? One time, it goes to 50. Mars leaves one time, Jupiter leaves once, Saturn leaves once, and Neptune leaves once, and Pluto leaves once. Remember, if the input that you see here and every one of these parts leaves one time, then this whole system here is going to consider to be a function. For an example of one that would not be a function, if Venus left twice, so went to 50 and then Venus went to 62. If you saw two arrows coming from Venus, then this whole input output would not be a function. So if it leaves one time, you put yes, it's a function. If you see it leave two or more times or repeat it two or more times, then no, it will not be a function. Now notice here, this is only for domain. Notice that 50 has 2. We don't care about range when we're talking about function. It's just the input or domain when we're talking about function. So long as everything leaves one time, this whole system here is a function. So just to kind of recap how to determine if a graph is a function now. So this is how we're looking at a picture or a graph on the x and y axis. Again, it's the same thing that happens. The x values can't repeat. That means it has to only state it one time. The graph is not considered to be a function if x it repeats two or more times. So if you actually see the x values repeat, then again it will put no, it's not a function. The best way to test is to use a vertical line test. This is where we draw an imaginary line through the graph, and we're going to count how many times that our vertical line hits our actual graph. If it hits it 2 times, once again, it's not a function. If it hits it only once, then it will be considered to be a function. So let's do a test. So here's my x, my x and y axis. This is my x and y axis. These are my graphs. I'm going to draw an imaginary line. It does not matter where you draw it. I can draw it here. I can draw it over here. My goal is to see if I can draw a vertical line and see if this graph hits it more than one time. If I draw it here, it only hits it one time right here. So this is considered to be a function. If I draw the vertical line over here, I only see it hits it one time. Draw it here one time. However, I get down to here and I draw a straight line all the way down. It hits it one time, two times. So this one here is the only one that's not considered to be a function. So just to kind of recap, here's my line. Hits it one time, it's a function. Graph hits it one time, it's a function. Even if I drew it over here, it still hits it one time. It's a function. I drew it over here, function. However, for this one, 1, 2. 2 or more, not a function. Let's talk about ordered pairs again, just to recap. Ordered pairs, we have our x and a y. X is going to be our first coordinate, y is going to be our second coordinate. So when my MathFast Plus says a function of x is equal to y, that's all that means when you see this here. So 1, when we have 1 is equal to -10, this is considered to be an ordered pair. 1 is going to be my x, -10 is going to be my y. So f of x is equal to y. X is always going to be inside the parentheses. Y is going to be on the output on the opposite side of the equal sign. So this is my x and y. This creates my ordered pair. Use the graph of the function to write the corresponding ordered pair. It will be 10, comma, -1 for this answer. Domain and range. Now, domain and range can be tricky. So we'll kind of go through and make sure we understand fully on how to figure out the domain and range of graphs. Again, to recap, domain deals with the x value. So what we're focusing on, again, is just left and right, horizontal, when we look at a graph. Range, however, deals with the y values. That's going to be up and down. If you were to write down these 4 questions and leave a space on it for your answer, I feel like you have a great understanding of how to find the domain and range. First question is, when we look at the graph, how far left does the graph go? So we're going to look at a graph and see how far left it go. We're going to write our answer here. How far right does it go? We're going to look at it and see how far to the right it goes, then write our answer here. So we have our 2 answers here as far as the answer for domain. Now we're going to look at range. How far down? Yes, you have to say down first. It has to be in order. Number 3, down. How far down does this graph go? Write our answer. How far up does it go? Then we write our answer. The conclusion of these 2 answers will create our range. So let's go through before we go through the examples, let's talk about the interval notation. If you see an open circle or numbers here not included, that means we're going to be putting parentheses around it. An open circle means that the graph does not touch it. It can go near it, but never touches it. That's what an open circle means. When we see the infinite sign, the infinity sign, that's like a sideward 8 laying down. They always get parentheses because ask yourself, can we ever touch infinity? Can we ever tell me the definite number of infinity? It's not, because infinity keeps going on forever. So that's why it'll always get a parentheses, because we can't never touch it. Closed circles, however, they get the brackets. That means if you go to look at the graph and it has a closed circle at the end of the line, then we're going to write the bracket and then write in the number that it is. That means it touches the graph. So therefore, for example, there are going to be a few times where you can have both. The graph goes all the way to the left. It says how far left? It goes to -5. Does it touch it? Yes, it does. Bracket. How far right does it go? That's going to be our answer for the second part of our question. It goes all the way to 10, but does it touch it at 10? No, because it probably has an open circle. Same thing with inequalities. If you see a less than or greater than, then this is going to consider to be it does not touch. So that's why we get parentheses. Infinite, again, another statement that you would use that you see in my math lab for the answer to be infinite is all real numbers. So what does infinite mean? How far left does it go? How far right does it go? Sometimes your graph will go to negative infinity. And then how far right does it go? Well, it goes to positive infinity. That means it's all the real numbers. And this is what the symbol looks like. It looks like a 2 lines with an R here and darker for all real numbers. So anytime you have in negative infinity to positive infinity for your answer for either domain or range, another way you can select your answer is just saying all real numbers. In closed circles, they have the less than or equal to marking on the bottom of it. I didn't put it here, but when it says less than or equal to or greater than equal to, this is considered to be a closed one, and we're going to use brackets for those. And that's for interval notation. So when you see an open circle, we're going to put less than or greater than. If you see a closed circle, we're going to put less than or equal to or greater than equal to when we're looking for inequality notation. So this is interval notation, and this is inequality notation. So this is what you also need to watch out for in my MathWise Plus, because they want you to put it in certain notation form. So let's kind of look at it. So here I'm going to ask you for what's the domain and range for this one. So what's our first question? How far left does it go? Now we want to probably say it goes all the way to -5 here. So remember, the domain deals with the x. So we're looking at left and right only. I'm not looking up and down. Left and right. How far left does it go? You probably want to say the answer is -5, but it doesn't. Because of this arrow is telling you that this graph continues on in this direction forever. It doesn't stop here. You'll see a close or open dot to know when the graph actually stops. But if you see this arrow, it goes into the left side, all the way to the left side to negative infinity. How far right does it go? It goes up here and stops at 3, but remember, it continues on with it because of this arrow. So the answer for this one is going to be all real numbers, or if you put it in interval notation, negative infinity, comma, positive infinity with parentheses around it. The range, we're going to ask how far down does it go? So how far down does this graph go? You think it might stop at -4, but it doesn't, because of the arrow again, it continues on to negative infinity. How far up does it go? To positive infinity, all real numbers. I like to put these little I like to try to box in the graph to kind of know what we're actually looking for. So how far left does it go? Will this graph eventually go past this line? If it does go past it, then that's what we know is going to be negative infinity. How far right does it go? You think you'll pass this? I think it will if you extend this graph out. So that's why it goes to positive infinity. How far down? It will pass this one here. So what we're trying to do when we find the domain and range is, can we kind of put a box around it? If this graph succeeds and goes past our box, then more than likely it always goes to negative infinity or positive infinity. So let's look at this one. How far how far left does it go? So if I draw a straight line here, I think it's going to continue. If I continue this graph on, it's going to go past this line. So how far left does it go? Negative infinity. How far right does it go? Positive infinity. So that means the answer is going to be all real numbers. For range now, first question, how far down does it go? Now this one here doesn't have arrows go all the way down. So it says how far down does it go? It looks like it stops at -4 on the y-axis. So that's what would be my first answer, -4. How far up does it go? Well, it looks like it goes past and continues on in the positive direction. So we put infinity here. So the domain all real because it goes all the way left, all the way right. Range, it stops down here and goes all the way up to positive infinity. So this is my marker letting me know it stops. So looking at this one here, if you want to pause the video and you try it before looking at the answer, but to go forward with this one, how far left? It goes all the way to the left, this side here, goes all the way to the right here. Again, it doesn't stop here, but it continues on because of the arrows. All real numbers for domain. How far down does it go? Negative infinity. These here are going all the way down forever. How far up does it go? Well, it doesn't go up into positive infinity. It stops right at 1 for the y-axis, for the range. So we put 1. Notice here I'll put a bracket because it actually touches it at 1. This is called a piecewise function. So how to graph a piecewise function and identify what the piecewise function should look like. Let me go back one. Okay. So the first thing we want to do when trying to identify, because you're going to be given some pictures and we need to figure out how does this piecewise function going to look and choose A, B, C, or D. The first thing we need to do is just put the first equation into our calculator and kind of see what it looks like. So let's do that real quick. So 7x plus 2. And we're going to hit zoom 6. And notice here, the lines looks like here. But as you can see from our graph, it doesn't go in this direction all the way up. It stops right here. So why does it stop right here? Because I'm only taking the x's that's going to be less than 0. So over here is +1, +2, +3, +4. I don't want to go further past here because all I'm looking for in this part here is all the x's that's less than 0. So the only be less than 0 is -1, -2 going in this direction. So from here on down is the only part I'm going to take. So if you want to, looking at this graph here, so another way of looking at it, this is what the full equation looks like for 7x plus 2. However, I only want the x's that's going to be less than or equal to 0. So looking at this one here, what I don't want is anything, because this is 1, this is 2, this is 3. These are going to be greater than 0, and I don't want that. So all this here, I don't need. So all I'm taking is from 0 to all the way down. This is actually going to continue on forever in this direction. So all these parts here going in this direction here is what I need. So the line that continues all the way down here is what the graph should look like. So it's going to stop here with a closed dot. So why is it a closed dot? Because remember, if we have less than or equal to or greater than equal to, this is considered to be a closed dot. If it was just greater than or equal to, then it'll be actually an open dot. So at the end of this, we have a closed dot here. Now the second one here, we're going to put this one in our graph and notice that it goes this direction. So once again, I'm not taking the full graph and I can show you what it looks like. Let's put it into, so 1/5 x plus 4. So here's the full length of the graph. And remember, the only part that we're looking for is the x's that's going to be greater than 0. So where are my x's that's going to be greater than 0? So you should all agree that my x is greater than 0 is anything going in this direction this way. That's going to be greater than 0, which means that I don't need any of this side over here. And where does it start? It starts right at 0, and this is going to be an open circle because remember, we're looking for x is less than 0. And remember, less than or greater than gets an open circle. So it's an open circle going in this direction for forever. So this is where we have from here to here is the 7x plus 2 with a closed dot because of the less than or equal to marking. And from here to here, we have an open dot for the this equation here. So one of the first things you probably want to look for to make the problem a little bit easier, just check for the open and closed circles. Less than or greater than and equal to, it has a closed one. Just the less than or greater than, it has an open one. So let's find out if we can do this is just another example as far as the finding out the domain and range, and we're going to make the piecewise function. So we're going to put this in our calculator. I know it's going to show a full length of the line, but we're only looking for the x's that's going to be less than or equal to 3. So we cut it off at 3 and just keep anything less than, that means all the way to the left for our answer. So here's my 3. I'm going to take only this part here. So I know your graph probably goes all the way up here, but I don't need this part up here because I want just the x's less than 3. So from here on back, and it's going to be a close because of less than or equal to sign. Put this in your calculator for the second one. the graph is going to look like this, going all the way down. But again, I want all the x's greater than 3. So here's my 3. I just want everything greater. That means going in this direction for 3. That's going to be all for this one. It's going to be an open circle because it's going to be less than, it's going to be the greater than symbol. So the domain, how far left is this whole graph? We're gonna put both of them together. I know they break off here, but we're gonna put them both together. How far left does this go? Remember, it keeps on going in this direction forever, so it goes all the way to negative infinity. How far right does this whole graph go? Well, this stops here, but remember, your calculator is actually not going to have an arrow, but you know that your graph continues on in this direction forever. So it's going to be positive infinity. What's the range? How far down does it go? Goes all the way down, goes all the way down. That means it's negative infinity. How far up does it go? Well, it stops at, these are actually going up by 2. So 2, 4, then 5. So it goes all the way up to 5, doesn't go any further. So we put 5 and we put a bracket because there's a closed dot here. So this is the domain in range. How to use the x-intercept to solve word problems. So here we have a ball that's thrown from the top of a 80-foot building with a velocity or speed of 64 feet per second. We want to know try to figure out the height of the object after t seconds. So when I throw it up, what is the when will be the actual time it actually hits the ground, which means it ground zero. So let's kind of draw like a little picture of diagram what it kind of looks like. So excuse my drawing, but I do the best that I can. Here's my building, and we're going to have a little person up here. And we're going to throw the ball into the air, and we want to know when will it hit the ground. So right here. So at what time will it hit the ground? So remember, this is a height for the building of 80 feet. This is going to be considered to be the maximum height. But when it comes all the way down, this is actually going to be ground zero. So we want to know when it actually hits the ground at zero. So let's use the calculator to help us figure out what the answer should be. So here's our equation here. Instead of t, we're going to put x in our calculator. So negative 16, because the calculator won't recognize t. So we have negative 16x squared plus 64x plus 80. And we're going to put that in the calculator. Sometimes when we have big numbers, it's helpful to use zoom 0. I know sometimes you hit graph or you hit zoom 6. That's just a standard graph, but hit zoom 0 so we can see what the picture looks like. Because these numbers are so big, it'll actually fit it to our calculator in the way it should be. And then for the second part in Y2, we're going to put 0 in the second part because that's going to represent the ground 0 for it. So let's go ahead and figure out what this answer was going to be. So we have negative 16x squared plus 64x plus 80. The second here, we're going to drop down here and put ground 0. So we're going to put 0 here for our ground 0. So zoom and then click on the 0 to make it fit. So here is the top of the building. We're throwing it, well, this is actually the building. We're going to throw it in the air. And we want to know where it hits the ground right here. So the red represents the ground. The blue represents the picture of what the ball is the trajectory of what the ball should be. So this is where it hits here. So this is where we're going to hit second trace to get to calc. So we want the calc button. So we hit second and trace, and we're going to go right down here where it says intersection. So number 5. We hit enter, and what we're going to do is we're going to take this little cursor where we think it hits the ground at the ball. So here's you can pretend the cursor is actually the ball. So we throw the ball up. So just to kind of give you an understanding of the word problem, right at this point here when the ball is in the air, It took 2.8 seconds for the ball to go 131 feet in the air. So at 2.8 seconds, the ball is 131 feet in the air. But let's keep it going and get it real close to where we think it hits at. So it don't actually have to be on it. It can be somewhere near it. Then you're going to hit enter 3 times. 1, 2, 3. And here's our answer. After 5 seconds of we throwing the ball from the building, after 5 seconds, the ball will hit the ground. So an answer for this one here, when it asks for when will the ball hit the ground, it'll hit it, the ball, the object will hit the ground when the time is 5 seconds. So this is the conclusion of, this is actually a combined session of section 15 and section 16 to help you with Math Labs Plus.